Question 1. Part A, write down the modal class. Well, modal means most, so which frequency happened most often? Something happened 19 times. What happened 19 times? The parcel weighed between 0 and 1. So just copy out that inequality there. Now for part B, work out an estimate for the mean. So 19 parcels weighed between 0 and 1 kilograms, 12 parcels weighed between 1 and 2 kilograms, and so on. But we don't actually know how much each of these parcels actually weighed. It could be just over 0, it could be nearly 1, we just don't know. So this is where the estimating comes into play. We have to just assume all 19 of these parcels here weighed 0.5 kilograms. We go straight down the middle, we take the midpoint. So the midpoints are 0.5 kilograms, 1.5, 2.5, 3.5 and 4.5. And from then onwards we just use these midpoints. We just assume all 19 of these parcels weighed 0.5, or 12 of these parcels weighed 1.5, and so on. So we then cross multiply. So 19 parcels weighing 0.5 kilograms each, that's 9.5 kilograms, and so on. 12 times 1.5, 5 times 2.5, and so on. That gives us all these little subtotals here, which we then add up, giving us a total weight of the 40 parcels of 56 kilograms. So an estimate for the mean is going to be 56 kilograms divided across the 40 parcels. Make sure you divide by 40. Do not be tempted to divide by 5, the number of rows. So it's 56 divided by 40, and that's 1.4. Now be careful with your final answer. Do not round it. This estimating is all to do with the assumption we made at the beginning that the weight here was 0.5 kilograms and so on. So this is the estimating up here. Do not start rounding down here. Question 2. So we've got the ratio of girls to boys is 2 to 7, and we've got 170 girls. So how many boys have we got? Well, we're following this ratio of 2 to 7. How do we go from 2 to 170? Well, that's multiplying by 85. 170 divided by 2. So to get from the ratio to the actual figures, we're multiplying by 85. So how many boys have we got? 7 times 85, which is 595. So how many children have we got in total? Add the girls and the boys. 170 at 595 gives us 765 children. Now we're told that 3/5 of the people are children, so 3/5 is this 765 children. So 3/5 is represented by 765. Now the adults are going to be the rest, so they're going to be 2/5 worth. So this is 3/5, we want 2/5. So we take our 765, divide that by 3 to get back to 1/5, multiply that by 2 to get the number of adults being 510. So that was 765 divided by 3 and multiplying that by 2. So final answer, 510 adults in the cinema. Question 3a. Well, when we're multiplying, we add the powers. 5 add 9 is 14, so y to the power of 14. Now part B, we need to have each of these components to the power of 4. So 2 to the power of 4 and also m cubed to the power of 4. Now 2 to the power of 4 is just 2 times 2 times 2 times 2, which is 16. And when you've got a power inside the bracket and a power outside the bracket, you multiply these numbers together. So that's m to the power of 12. So 16m to the power of 12. Now part C, we start off by expanding the left hand side. So the claw, 5 times x is 5x, 5 times plus 3 is plus 15. So 5x plus 15 equals 3x minus 4. Subtract 3x from both sides. We get 2x plus 15 equals minus 4. Subtract 15 from both sides. We get 2x being minus 19. Halve both sides. We get x being minus 19 over 2. That's fine as a final answer, but you could have put it as minus 9.5. Now part D, we've got to factorise this quadratic. So it's going to be a pair of brackets with the first term being an x, and then we need to work out these two magic numbers. Now these two magic numbers multiply to be the number on the end, so multiply equal minus 24, but at the same time these two magic numbers have to add up to the coefficient of x, so they've got to add up to plus 2. So what two numbers multiply to make minus 24 but add to be 2? Well, that's minus 4 and plus 6. So our final answer is x minus 4, x plus 6. Or we could have written it the other way around. So this bracket first, x plus 6 times x minus 4. In D part 2, we're just building upon this factorising we've just done. So x minus 4 times x plus 6 has got to equal 0. So what value of x makes this first bracket 0? Well, that's x being 4. Alternatively, what value of x makes this second bracket 0? That's x being minus 6. Question 4a part 1. So write down the numbers that are in the set A. So A is just this circle here. So all the numbers in that circle, including this bit here. So 1, 2, 3, 4, 6, 12. Now A part 2, B union C. This means they're in B or C or both. So all the numbers in the B circle and the C circle. So that's 1, 3, 5, 7, 9, 10 and 11. Now part B, Brian writes down the statement A intersection C equals an empty set. So this is correct because this means that there are no numbers that are in both A and in C, and that's correct. A and C do not overlap, so it is true. There are no members in both sets A and C. Now part C, one of the numbers in the Venn diagram is picked at random. Find the probability that this number is in set C dash. Now this means the complement of C, so this just means not in C. So we've got to find the probability that if we pick a number at random, it's not in C. So how many numbers are not in C? Well, we've only got two numbers that are in C, so we've got to add up how many numbers apart from these two here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 numbers that are not in C. Now that's 10 out of 12 numbers, so find the probability that this number is not in C is 10 out of 12, which you could have simplified to 5 over 6 if you wanted, but you didn't need to. Question 5. So write 8 times 10 to the 4 as an ordinary number. Well, just literally pop this into your calculator, press equals, and you get 80,000. Now for part B, pop this into your calculator, taking advantage of that fraction button, the one with the white rectangle over the black rectangle, which is usually 3 down on the left on a standard calculator. So make this the denominator, make this the numerator, make this the denominator. Now your calculator might go to straight to final answer, or it may give you 0.0005. Now we've got to give your answer in standard form. So remember, the first number's got to be between 1 and 10, so that would be 5 times 10 to the power of something. Now because this is a very small number, the power is going to be negative, and then really the number we then include as the power. Just think how many hops the decimal point has had to do. So it was originally here, it needs to end up being after the 5 to give us this 5. So that's 1, 2, 3, 4 hops. So 5 times 10 to the minus 4. Question 6. So we have to work out the circumference of the circle. Now the circumference equals pi times diameter. Cottage pie is delicious, apple pies are too. That might be a way you remember this. So we're going to need to know the diameter of this circle, so the length from M to N. Now M to N is the hypotenuse of this triangle MPN, this right angled triangle. So we can work out the length of MN using Pythagoras. Side, side, find a side. So MN squared equals 3.5 squared plus 9.7 squared, which is 106.34. Square root this, we get 10.312 ... So circumference equals pi times the diameter. So pi times our 10.312 gives us 32.396 ... which to 3 significant figures is 32.4. Remember, 3 significant figures just means 3 numbers in your answer. So the 32 And do we round the 3 up? Yes, we do. So 32.4. Question 7a. Work out the value of the boat at the end of 3 years. So the boat depreciates, that means loses value by 4% each year. So if we had 100% to start with, each year we're losing 4%, leaving us with 96 at the end of the year. So what's our multiplier if we have a 4% depreciation? Is 0.96. That's the 96 divided by the 100. So that's our multiplier, so we can then just go straight to final answer. 160,000 multiplied by 0.96 to the power of 3, because we're looking at the end of 3 years, giving us this, which to the nearest Hong Kong dollar is 141,558. Now for part B, Jalina gets a salary increase of 5%. So if we had 100 to start with, we're getting an extra 5%, a plus 5, giving us 105. So our multiplier to generate a 5% increase is 1.05. Now the salary increases to 252,000. That is our salary after the 1.05% increase. So going back to the original salary, we've got to take our 252,000 and divide by 1.05, giving us 240,000. Question 8. So find the highest common factor of A and B. So here we go and take the, when we go and compare the components of A and B, we're taking the lowest power each time. So when we're looking at the 2's, well, we've got effectively 2 to the power of 0 and A, so no 2's. And then we move on to 3, our lowest power is the 3. And then 5's, our lowest power is a nothing, because there's no 5's in B. And then moving on to the 7's, our lowest power is 7 to the 3. So 3 times 7 cubed, which is 1029. Now this compares to the lowest common multiplier, where we take the highest power when we compare the two. So 2 cubed is the highest power for 2, 3 to the 5 is the highest power for the 3's, 5 to the 1 is the highest power for the 5's, and 7 to the 4 is the highest power for the 7's. Multiply these together, we get this number here. Now part B, let's start off with the first fact, that we're told the highest common factor of B and C is t cubed times 7. So the highest common factor of B times C is t cubed times 7. Now the highest common factor is when we take the lowest power when we compare the two. So we can see that P must be, because we've got a 2 to the cubed, 3 must be the lowest power. So P is greater than or equal to 3, so we can't work out P yet. But when we compare the two, we can see that R must be 1, because we've got 7 to the power of 1. So when we take the lowest power when we compare these two, the R must be the 1. Now, moving on to the second fact, the lowest common multiple of A and C is this. Now this is when we take the highest power when we compare A and C. So comparing A and C, well, we've got our 2 to the power of 4 must come from this, so P must equal 4. Then we've got 3 to the power of 5, which is not relevant to this on this occasion. Then 5 squared, well, that just must mean, as we're comparing A and C, that our highest power of 5 is going to be squared. Well, that must mean that Q is equal to 2. So P is 4 and Q is 2. So overall, we got R equaling 1 derived from this first fact, and then P being 4 and Q being 2 derived from this second fact. Question 9. So in order to work out the perimeter of this shape, we're going to need to have worked out these other two lengths from this right angle triangle. So I'm calling this length X and this length Y. So using SOHCAHTOA, I can say tan 72 is my opposite 12.8 divided my adjacent side of X. Multiplying by X and dividing by tan 72, we can see that X equals 12.8 over tan 72, meaning that this length here is 4.158 rounded. Now this length here, the hypotenuse, by sin 72 is going to be our opposite 12.8 over our hypotenuse y. So rearranging this, we've got y equaling 12.8 over sin 72, which is 13.458 roughly. Now when we go and look at this diagram, we can see that our sides comprise two lengths. We first of all got this longer of the two shorter sides cropping up a lot, this 12.8, so that's here, 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 here and here. But then what we've also got, we've got this length here, which is the length of the hypotenuse take away the length of the shorter side. So just go over that again. So it's the length of that length there is the length of the hypotenuse all the way down there, but less this length of the shorter side. So that's my y minus x, which gives me, so y take away x, I get 9.2997 dot dot dot. So each of these lengths here are all of these 9.2997s. So what's my total perimeter? Well, I've got 5 of these 9.2997s, 5 of my 12.8s. When I go and add these together, I get 110.49 dot dot dot, which to 3 sig figs is 110. 111 was also allowed because it was very easy to just go over the 110.5 if you didn't stay very accurate throughout. So if you've got 111 here, that was still allowed as being a correct answer to 3 significant figures. Question 10. So use the graph to find an estimate for the interquartile range. So the interquartile range is what happens when you take your 3/4 of the way up value subtracted from the quarter of the way up value. Now a quarter of 80 is 20, 3/4 of 80 is 60. So we're going to take readings from our cumulative frequency at both 20 and 60, and that gives me 123 and 103. Subtract 103 from 123, you get 20. Now part B, Claire says more than 35% of the films are over 120 minutes long. Is Claire correct, and give a reason? So let's take our 120 minutes here in red, take a reading, I get 55. So we're talking about more than 120 minutes. So the number of films that is my 80, take away my 55, which is 25 films. Now 25 out of 80 is 31.25%. So this is not more than 35%. So Claire is not correct. Question 11a. So we just have to multiply out these 3 pairs with these 3 brackets. Now I've started off by multiplying out brackets 2 and 3. So x plus 3 times x minus 5, which I've done over here as a side working. X times x, x times minus 5, 3 times x, 3 times minus 5. Gather up your middle terms, the x terms, and you get x squared minus 2x minus 15. So I've then taken this x squared minus 2x minus 15 and multiplied that by bracket number 1. So again, the claw is going to be sort of a 3-way claw. So 2x times x squared, 2x times minus 2x, 2x times minus 15, giving me those 3 terms here. Then moving on to the minus 1 times x squared, minus 1 times minus 2x, minus 1 times minus 15, giving me these 3 terms here. Now then, gathering like terms, I've got 2x cubed minus 5x squared minus 28x plus 15. Now for part B, we've got to solve this quadratic equation. It's not going to factorise because we've got to give our solutions to 3 significant figures, so there's the big clue. I mean, you can try and see if it would factorise, but it doesn't. So you've really got a choice. You can either use completing the square, which I think is a bit tricky on this occasion given we've got the 3 in front of the x squared, but you could do. But I think it's easier just to use the quadratic formula. So a is the coefficient of x squared, which is 3, b is the coefficient of x, which is the 6, and c is minus 5. So substitute these into our quadratic formula here, and we get this. Tidy up under the square root, we get root 96. So my two solutions come from, first of all, minus 6 minus my root 96 over 6, which is minus 2.63299 dot dot dot. And my second solution comes from minus 6 plus root 96 all over 6, which is 0.63299 dot dot dot, giving our solutions to three significant figures. That's minus 2.63 and 0.633. Question 12. So part A, write down the solution of this simultaneous equation. Well, there's only one mark going for this, so there can't be a lot of work to do. The solution is simply where the two lines cross, so that's where x equals 3 and y equals 4. Now for part B, I'm going to choose to shade the unwanted areas, so just make it clear if that's what you're trying to do. So let's start off with x being greater than or equal to 0. So x equals 0 is the y-axis, so I want all the values to the right of that. So my unwanted area is to the left of that line, which is what I've shaded there in blue. Similarly, with y being greater than or equal to 0, I want the values above the x-axis, so shading the unwanted area is that purple shaded area below the x-axis. Now, x plus y being greater than or equal to 4, let's start off by drawing on our graph the line x plus y equals 4. Now it's a straight line, and then just a couple of points, so for example 4, 0 and 0, 4 will be when they two together add up to 4. So popping in that straight line there in red, x plus y equaling 4. Now I want the values above that red line, so shading my unwanted area below that red line is that red shaded area. Now with the two lines that we've been given, the 3y equaling 2x plus 6 and the 4x plus 3y equaling 24, you've just got to concentrate a bit to make sure you shade the appropriate area. So I'm just going to take the point 0, 0 each time and just think whether that's a wanted or an unwanted point. So substituting in 0, 0, I get 0 being less than or equal to 6. So 0, 0 is a wanted value. So I'm going to have to shade the bit that does not include 0, 0. So that's shading above the line 3y equals 2x plus 6, which is that bit shaded in black. And then finally with the 4x plus 3y being less than or equal to 24, thinking about the 0, 0 again, I get 0 being less than or equal to 24. Now that's a value that I want. So again, that's a wanted value. So with regard to which side do I shade, I'm shading to the right hand side of that 4x plus 3y equals 24, which is that bit shaded in green. So that leaves this area here as my only unshaded area. So that is my region R. Question 13. Find the size of angle NOM, this one here. Well, that's 54 degrees because the angle at the circumference is half the angle at the center, or in other words, the angle at the center is twice the angle at the circumference. And part B1, find the size of angle NMQ, N to M to Q. Well, that's 27 degrees. That's just that sort of strange circle theorem, the alternate segment theorem, telling us that that there and that there are equal. Question 14. Part A, we just need to substitute minus 7 into the f function. So 3 lots of minus 7 minus 5 is minus 26 all over 4, which is minus 13 over 2. Could have said minus 6.5 if you wanted. Now for part B, we've got to express the inverse function f to the minus 1. Now to do this, we need to change the subject. So choose to go and let y equal 3x minus 5 over 4 and just change the subject. So multiply both sides by 4, add the 5, then divide by 3, gives us x equaling 4y plus 5 over 3. But do remember, y is just something we've artificially introduced, so our final answer is going to be f to the minus 1x equals 4x plus 5 over 3. And remember what this does. This just undoes whatever the f function does. So if, for example, if we were to go and pop our minus 6.5 into this inverse function, we get back to our minus 7 where we started. Now for part C, we've got to find fg of 3. Now be careful here. This is when you substitute 3 first of all into the g function and get an output, and substitute that output into the f function. So get it the right way around. So popping a 3 into the g function, we get 19 minus 3 being 16, square root of 16, which is 4. And then we take this 4 and substitute that into the f function. So 3 4s are 12, minus 5 is 7, 7 over 4, which is 1.75 if you liked. Now part D, which values of x cannot be included in any domain of G? So for what values of x will we not get a solution? Well, you cannot square root a negative value. So the second x goes over 19, it's not possible to square root it. So which values cannot be included? All values where x is greater than 19. 15 part A. So start off by dealing with the minors part of the index. So for the minors we just flip it over. So flipping over the fraction, so we've now got y to the 8 as the numerator and 256x to the 20 is the denominator, and that has sorted out the minus component. So we've now just got it to the power of a quarter. So applying this quarter to each of the 3 components, y to the 8 to the power of a quarter, multiply the 8 by the quarter gives us y squared. Now what's the quarter root of 256? What number times itself times itself times itself again gives us 256? Well, that is 4. Now you would work that out on your calculator by popping in 256 to the power of 0.25. Then finally, what is the quarter root of x to the 20? So again, you just multiply the 20 by the quarter, giving us x to the 5. Now for part B, start off by factorising your the denominator of the 2 terms. So 9x squared minus 25, well, this is a difference between 2 squares, so that's 3x plus 5 and 3x minus 5. And then factorising this here, we get 2 lots of 3x plus 5. Now if we want to subtract fractions, we need a common denominator. So to get a common denominator, we're going to have all 3 of these terms, this, this and this, in the denominator, but then also the missing part. So if we go and multiply top and bottom of this first term by 2, we've then got 2 times 3x plus 5 times 3x minus 5 as the denominator. We will need this same common denominator over here. So to bring this into line with this, we're going to have to multiply top and bottom by our 3x minus 5. So as you can see, we've got a common denominator now. Now just tidying up the numerator, 1 times 2 is 2, and then we've got to take away the 3x minus 5. But be careful, this is really, think of that minus 1 times both of these terms. So that's going to be minus 3x plus 5 as we on the numerator. So just tidying that up, that gives us 7 minus 3x on the numerator, and this still is the denominator. Question 16. So we're told that the volume of the frustrum to the volume of the large cone is in the ratio of 98 to 125. So the ratio of the small cone to the large cone must be 27 over 125, because the frustrum plus the small cone is the full 125. So in terms of ratio, small cone to large cone is 27 to 125 in terms of its volume. So the length ratio between the small cone and the large cone is going to be the cube root of the 27 to 125, which is 3 to 5. So our length ratio is 3 to 5. Now, just dividing both sides by 5, we could say that our length ratio is 3 over 5 to 1, or if you like, 3 over 5 h to h. So we're saying that the height of the small cone, is 3/5 of h. So if that's the height of the small cone, then the height of the frustum must be 2/5 of h. Question 17. Now we're told that the point B is 5/8, and to get from A to B you go 2 along and 7 up. So working backwards to work out the coordinate of A, we're going to go, A is going to be 2 back from 5, so it's going to have an x coordinate of 3, and y coordinate wise it's going to be 7 back from the 8, which is 1. So A is 3, 1. So just going over that again, A is 3, 1, because then when you add 2 to the x and 7 to the y, you get the coordinate for B. So if A is 3, 1, we can now work out what C is, because how do we get from A to C? We've got to add on 10 to the x coordinate and 11 to the y coordinate. So add on 10 to the 3, 11 to the 1, gives us the coordinate 13, 12. Now we're told that the point E has coordinates 63, 2, 1, 1. Use a vector method to prove that ABE is a straight line. Okay, now the vector from A to B, as we know, is 2, 7. Now going from B to E, so B all the way up to E is going to be, we're just going to have to take our 63 and 211 and take away what our coordinate is for B, which is our 5, 8. So taking away our 5 and 8, we can see that to get from B to E must be 58, 203. So just running over that again, B's at 5, 8. So if we then go and add on a 58 and 203, that will take us to our point E, which is 63, 211. So the vector from B to E is 58, 203. Now this is a multiple of our vector from A to B. Our multiplier is 29, because 29 lots of 2, 7 gives us 58, 203. Now given that AB and BE are both multiples of the same vector, they are therefore parallel. And because they both go through the common point B, not only are they parallel, but they must be lying on a straight line, so we can conclude that ABE is a straight line. Question 18. So as the changes inside the brackets, this affects the x value, but opposite to what you would expect. So we're going to be adding 5 to our x coordinates. So minus 2 minus 1 is going to become 3 minus 1 as we add 5 to the x coordinate. Now here the transformation, the change is outside the function. So this is going to affect the y value, and it will affect is exactly as you would expect. So this is going to halve the y value. So halving the minus 1, so the coordinate's going to become minus 2 minus a half. Now for part B, so first thing to note is that the height of our wave is now going all the way from minus 1 to plus 3. So that is a height in total of 4 compared to the normal sine curve, which goes between 1 and minus 1. So we're stretching in the y direction by times 2. So we can say that A equals 2. Because we're doubling the y value, values. Now, not only that, but we're also looking at the symmetry, or the peak and the trough. We're going between minus 1 and 3, so the y values have also shifted up 1. So our C is going to have to be plus 1. So with regard to the y coordinate, we've timesed it by 2 and shifted it up by 1. Now, let's just think of a point now. So let's think of 0, 0 on the original sine curve. So that's now what we're now saying is that's going to have doubled and gone up 1, but not only has it doubled to still be 0 and gone up 1, it's now shifted over by plus 90 degrees. So we're adding so plus 90 to the x coordinates. So as anything inside the function is opposite to what you'd expect, we're going to be writing x minus 90 degrees inside the bracket. So b is actually 90 degrees. Now I think it's worth just checking some values on this just to check that it's holds. So again, let's just focus on that point that I was just discussing, the coordinate 91. Let's just see that that holds. So if we go and substitute in when x equals 90, we've got 90 minus 90 being 0, sin of 0 is 0, 2 lots of 0 is 0, and then you add on the 1, we're going to get 1. So that point 91 holds. Let's take another point, for example 183. So subbing in our 180, we want to see if we get 3. So subbing in 180, 180 take away 90 is 90, sin of 90 is 1, 2 lots of 1 is 2, add on the 1, and indeed we do get 3. So that looks like it's right. Question 19. Now I think one of these sort of sample space diagrams is probably best to sort of help you gather your thoughts on this. So spinner A can land on a 2, 3, 5 or a 7, and spinner B can land on a 2, 3, 4, 5 or 6. And Jack wins, he wins the game if one spinner lands on an odd number and the other spinner lands on an even. So how many ways is he going to win? So he's going to win with a 2, 3, a 2, 5, 3, 2, 3, 4, 3, 6, 5, 2, 5, 4, 5, 6, 7, 2, 7, 4, 7, 6. So there are 11 ways out of 20 that he can win. Now he plays the game twice and he wins. We've got to work out the probability he wins both games. So he's got to win game number 1 and game number 2. Because it's an and, we multiply. So 11 11s are 121, 20 20s is 400. Final answer. Question 20. Now I thought this seems really quite complicated when you read through it, but I think if you just do a quick sketch, it helps you to gather your thoughts. So we've got point A being at 4, 7, and then we've got B and C lying on this line here. Now what I've gone and done, I've just gone and rearranged this into y equals mx plus c format. So I just divided through by 3. So y equals 2/3 x plus 4. So there's my line, y equals 2/3 x plus 4. So it's sort of a shallow positive gradient, and it's crossing over the y-axis at 4. And now what we've been told here is that B and C lie on the line with this equation. Okay, and then, but what we're being asked to do is to find an equation of the line of symmetry of triangle ABC. So we don't have to find out what B and C are, we've just got to find the line of symmetry. Now the line of symmetry is going to be hitting our line at 90 degrees. So at the end of the day, we've just got to find out the equation of the line which is perpendicular to our given line and goes through the point A. So pretty straightforward really. So all we're going to do, because the gradient of our original line is 2/3, the gradient of a line of symmetry, where you flip this gradient over and change the sign, so that's minus 3/2. So the gradient of a line of symmetry is minus 3/2. The line itself goes through the point A, so we can just use the formula y minus y1 equals mx minus x1. Well, the gradient is minus 3/2, and our x1 is 4 and our y1 is 37. Now what I've chosen to do at this step is really just to undo this dividing by 2. So I've multiplied throughout by 2. So 2y minus 74 equals minus 3 lots of x minus 4. Multiply out the bracket, I get 2y minus 74 equaling minus 3x plus 12. Now go and see how we've got to give our answer. We need the x's plus the y's equaling a number. So I've added 3x to both sides, added 74 to both sides, giving me 3x plus 2y equals 86.